Okay. So just so people know, we are recording this one, so we're gonna be uploading it on our YouTube channel. So okay. So let me get started so we can stick to the time. Okay. You guys can see my screen, right?
Yep.
Okay. Okay. Hey everyone. Thanks for joining. And yeah, it's good to have you. And in case if you guys don't know who we are and what we do, so it'll be a quick introduction to us. And we will be doing a Q&A session at the end. But it'll be nice if we can, interact during the during the podcast. So you guys can send in your questions on the chat, or you can, just interrupt us, raise your hand, and I think we'll unmute you, and you can ask your questions. Um, and I encourage people to, interact with us, and ask any questions. It doesn't have to be about data science and supply chain. It can be anything, career oriented, or uh, you know job, and so on, right? So anything you'd like to ask, you can ask us. But yeah, it'll be nice if you can stop and interact with us, because that way you'll learn something as well. And yeah, it'll be good. So yeah, so we are data to production. So data production podcast we started a couple of months ago, to help out basically beginners in data science, to make them understand the different areas, different industries where data science can be applied, and also, you know, to help them, what are the requirements, what are the things that you should be knowing in order to get into that field, right? So it started by me and Ashit, I think in December, and Shashank joined in, I think in Feb. So yeah, and then we are growing. So we're on episode 11 now. So all the episodes that we have done, they're on our YouTube channel. You can go watch them. Um, and yeah, if you have any questions, you can send us on LinkedIn, and we'll be happy to answer you. So for today's episode, we're going to be talking about data science and supply chain, but more sort of an automotive industry, um, and you'll see why. So let me give you a brief introduction to who we are. So Ashit, do you want to go ahead?
So hi everyone, my name is Ashit. I'm a data scientist at Piramal Finance. I've been working for about 2 years now, and I'm basically from civil engineering background. I did it from IIT Bombay in 2021, and feel free to connect with me on LinkedIn. Thanks.
Good. So a little about me. I graduated as a theoretical physicist, and then I transitioned into data science. Started out in healthcare as a data analyst, um, and then data scientist, again in physics, and then basically went into industry, to work in one of the largest sports retailer, Decathlon. So I work with Decathlon now as a senior data scientist, and you can connect with me on LinkedIn. My link's over there. So to today's speaker, well, we have another person actually. I forgot.
Yeah.
Shashank.
Hi.
Yeah, go ahead.
Yeah. Hi guys. I am Shashank. I work as a data scientist in Geo. I have approx 5 years of experience. We are mostly in retail and multimedia. So yeah, that's a brief about me. You can connect me on LinkedIn.
Okay, thank you. So on to today's speaker. So we are excited to have you, Adam. Thanks for joining. Thanks for taking time out. Um, and do you want to introduce yourself?
Thank you. So yeah, I'm Adam. I've been in the auto industry most of my career. Started as a data analyst, did some software engineering as well. Actually, the date here is wrong. 2018, I started at Ford Motor
Whoops.
Company, but that's okay. That's okay. Yeah, I spent 3
Last minute
years at
typo.
at Ford was 2018. Marpos was 2017.
Okay.
It doesn't matter, but so then I worked at Ford for 3 years, working in operations research, mostly around vehicle routing and scheduling. And then I'm now work at Toyota and I work within the supply chain group. So working on various data science and operations research applications within supply chain.
Okay, thank you, Adam. And yeah, sorry about the typos. It was last minute change. We completely forgot
Yeah,
about it.
I know.
We had a slides to it, so just for people, yeah. So yeah, you can connect with them on LinkedIn. If you're interested to learn more about how data science is in automotive industry. Yeah. So yeah, so let's get started on some exciting stuff, right? So we'll start with your background actually. So what's your background and how did you get into data science? Or let's say, how did you start it out as a data analyst or software engineer?
Yeah, so formally, I went to my undergraduate, studied many different things, but ended up settling in mathematics. So I did my bachelor's in mathematics, and upon graduating from that, I started working at Marpos, where I was doing basically a data analyst co-op. So I was working in the quality department there, kind of just doing analysis on like what projects are happening, how much money we're spending, where can we send different resources, like how to kind of make the project operations a little more efficient. And then during that time, also when I was at Marpos, I was working on my graduate degree in applied mathematics. And then from at Marpos, while doing my degree, I also switched to the electrical engineering department where I was doing kind of software engineering, kind of totally unrelated to data science, but I knew that's kind of what I wanted to do based on my education. So, because I was studying mathematics at the time, and the mathematics I was studying was discrete optimization, like discrete mathematics, so discrete optimization, mathematical modeling, like linear and integer programs, similar to operations research, and then it overlapped a lot with computer science. So I knew I wanted to do something like that, and right after I graduated with my master's, I took a role at Ford Motor Company. So that was 2018. I took a job at Ford Motor Company, and that was in the operations research group. So I started working on multimodal journey planning optimization problem, which was at the time Google Maps didn't have this. They have it now, but it was if you started at any given point in the world and you wanted to go to any other point, so it didn't have to be on a road network. It could be. How do you get there with like walking, biking, and public transit, right? So actually, India was one of the main places that we were targeting to use this. So you start anywhere, you want to go somewhere else. How do you get there? Walking, biking, maybe you use a bus, maybe you use a train, whatever it might be. And there's kind of different ways that you can optimize it, right? Like you could do the shortest path. So like what's the quickest way to get there? Or what's the most convenient way to get there, right? So maybe you might get there 10 minutes earlier using uh, but you'd have to like switch from train to bus and then walk a little bit, but you might save some time, but maybe there's like a convenience factor, right? So maybe if you just went on a bus the whole way, you might get there 10 minutes later, but it's more convenient. So it's kind of this like there's multiple objectives that you could solve for.
Also,
So I work. Go ahead.
what about, so there's, you can optimize for time. You can also optimize for fuel, right? And so for the time, you have to take in account the traffic, right? Or do you not take that into account?
Yeah, so this okay, so there's two things I worked on. This multimodal journey optimization doesn't use cars. So this is different from traveling salesman or anything like that.
Okay.
This is more of a just somebody walking. So you don't really consider traffic in this case because traffic is kind of irrelevant to most of the public transit except for buses. But that did get factored in. So there actually was like a machine learning part of the project to determine when buses would arrive because usually they come late, for example. but it was really a dynamic programming application. And then another thing you can optimize for, which is the fare cost, like how much does it cost to complete the journey, right? And there's all different kind of rules about if you buy a bus ticket, maybe you can use it for 2 different transfers, or maybe you can use you can buy one that's unlimited transfers, but it's only good within an hour. So that was the first project that I worked on. After that, I moved to vehicle routing, which is what you're talking about, where traffic gets considered a lot more. So because now you're in a car. So vehicle routing problem is an extension of the traveling salesman problem. So in the traveling salesman, you're trying to visit every city the cheapest way possible. Cheapest might mean time, or it might mean money. It might mean whatever it is, whatever the business objective value is. So vehicle routing is very similar, but imagine there's multiple traveling sales people and they're working together at the same time. So you have a fleet of vehicles and they all need to do certain pickups and drop-offs. So that's the vehicle routing problem. For that, yeah, you do take into consideration traffic times. So we can go into that in more detail if you want. I don't know what you want.
Question about the maps that you mentioned, right? So Ford, for example, right? So the maps that comes in the car with, when you buy Ford. So the optimization that's done on the maps. So is it you, like the Ford, who does it, or is it depending on which? So if you're using Google Maps or versus the other ones, is it them who does it? So who are in charge of doing the optimization for different routes?
So usually in a car, for a private individual, you're usually just using like a Google Maps, right? Or
Right.
maybe using Apple Maps. So Google or Apple.
So back when
So
2018, when Googles were not around, like when you said like
Google
Maps
that
weren't
was
that
for the
famous back then, right?
Well, no. Google Maps was still used for vehicle routing, but they weren't
Right.
used for the walking and public transit part as much. So
Got it.
yeah, we're conflating 2 different things. But yeah, so like the
Also-
walking
okay.
public transit part. But
Also-
what I worked on is not individual car, like how you go from point to point, but it's more of so like if you had to manage a fleet of vehicles, how do you schedule them? So for example, if you had like one of the applications we worked on was like grocery delivery, for example. So if you wanted to use autonomous vehicles to do grocery delivery, how do you schedule them all throughout the city as one unit working together? And that's the big distinction between like what Google Maps does, because that's, for a single car, how do you get from a point to a point?
Right.
But this is how do you get a fleet to work together? So it's one level higher, right? Because
Right.
a car, like, you get what I mean. So
Actually, you were question.
Yeah. So in the last podcast episode, we had Nitin up, right? So his company actually works on these maps for different companies. So like Mercedes, BMW, they use their maps instead of Google Maps in their cars.
Yeah, it's a good point to mention. Yeah, that's pretty amazing, right? How different companies are making use of data science to solve different problems and then have their own solution in the cars, right? That's cool.
Yeah, so this is more of like so you can think of this as more of like a commercial, like, so it's not for an individual car, it's for like a fleet management system trying to dispatch multiple cars to work together. So it's not for a person to use. These applications that I was working on are for like a company would use them, or a subsection of a company that did fleet management. So it's kind of that, I don't know, is that clear, the distinction? So
yeah.
if like, for example, there's like a non-emergency medical transportation group that we worked with.
Right.
They have a bunch of basically ambulance that they need to send to pick up people. So how do they schedule all these vehicles to pick people up, including like ride share? How do they send different vehicles to pick up different people and bring them to their appointments? So it's not an individual car level basis. It's how does the whole fleet operate together and work in sync with each other? So it's not for a consumer to use, or not for like a
Mhm.
traditional consumer that drives a vehicle. It's for a company that is going to manage a fleet of vehicles.
Mhm.
That's the
And
main
we have a
difference.
question from the participant, and I think it's something that I was going to get onto was the algorithms part, right? How complicated can the algorithms get in this optimization? And the question that we have from the participant is, what was the algorithm used to solve VRP, heuristic, or exact optimization?
Yeah, so for the vehicle routing problems, what I was working on was done. So there's two things that you can do. One, if everything's going to be scheduled ahead of time. So if you think about trucks, like trucking was another example to use vehicle routing. Because again, you fill these trucks up with a bunch of parts that need to be delivered, and then how do they operate together to go send the parts out to different locations, pick new parts up, and maybe transfer them. Now, if it's all planned ahead of time, and you have the schedule for the day, you want to come up with a schedule for the day, and then you can send them out, and then they do their thing, and then they come back at the end of the day. For that, you can use an exact optimization technique. So you can use something like mathematical programming, like linear or integer programming. But for some situations like grocery delivery, that might not be planned out, right? You might get calls that come in on the fly. So somebody might call and say, or, they put in an order like, they want groceries today. Well, in that case, you can't plan ahead of time, and you need to give a response back right away. So when you need to give a response back right away, you need to switch to some type of heuristic, because these exact optimizations, they solve really slow. So in a trucking example, you have the whole night to plan. You can let the solver run all night, and then you can get an optimal solution. But if you're doing something like a ride hail, like Uber, for example, you don't want to put in a request to be picked up and then wait 20 minutes to get an answer of when you're going to be picked up, right? You need to get an answer right away. So you can use heuristics, and the trade-off with the heuristic is that you get a response really quick, but it might not be the optimal solution. It'll be close to optimal, but it probably isn't the optimal solution. So if you're doing real time, it'd be heuristic. If you have time to plan ahead of time, you do something like mathematical programming.
Here we have a question from someone. You can unmute yourself and feel free to ask.
Yeah, hi, this is Sabarish. So when you told about grocery deliveries, right? So there is one startup called Locus. It's not startup, but it's a few years old already. So is it similar to that you are talking about? Your competitor?
Where is the startup based? Is
Pardon
it
me?
global, or where is the startup based? Is it global?
Yes, this company.
Locus.
What is it?
So I think it's similar to Uber Groceries. If
No,
Adam
actually,
hasn't heard about that.
if you means if in Big Basket and all, they use Locus software for the route optimization. That means what it happens, suppose you have 10 deliveries, okay, then which one has to be delivered first? So accordingly they will stack the products, okay, in that delivery van,
Right.
so that they will optimize. So that's what he was talking about,
Yeah.
the groceries.
Yeah,
So
this
based
is
on the
similar.
dimensions, so that the last, like first in last out, okay, or last in first out, LIFO. Okay, the stack will be LIFO, so the last one will be delivered first, okay. So that route will be optimized, and accordingly that boxes will be stacked in the van. So is it similar problem you worked on, Adam?
Yeah, it's a similar problem, but we didn't do the bin pack. They call that a bin packing problem when you decide how to pack the truck. So basically what you do first is you solve the vehicle routing is really not actually routing. It's determining the sequence of pickup and deliveries.
Yeah.
So it's called vehicle routing, but it's not actually like turn left here, turn right. It's not that type of routing. It's actually a sequence of pickup and deliveries. So that's exactly what you're saying. So I worked on that part of it. What order do you do things in? And you use the turn by turn navigation as kind of a input to when you're solving the problem, because how you do the turn by turn determines the length of time. to go from a point to a point. So that's an input to the problem. And then once you get the sequence solved, then there's usually another team that does the bin packing problem, which is what
Okay.
you're talking about doing. Now, what I worked on, we didn't do a lot of things that were with big trucks. A lot of it was like a ride hail application. So you're picking up people. So we didn't have to worry about how we pack the vehicles as much.
So I just have one question. So in optimization, so means how you model this or optimization problem, like you have used gradient descent algorithm to reach the minima, or
Yeah,
okay,
so the actual
non-convex
optimization.
optimization.
Yeah, so when you're doing when we did large scale truck routing, that you would use some type of linear programming. So you'd use some tool like Gurobi or Cplex. But when we do these real time dynamic optimizations, you use heuristics. Some of the heuristics that are commonly used are genetic algorithms. That's the really big one. So genetic algorithms and simulated annealing. Those are probably the two most popular things.
Okay.
So
Eh,
when you have to decide the sequence of picking up or dropping off, right? So usually how many points are there in the sequence?
It
Because
depends on
if there are lesser points, you can just brute force it, right? Just check all the combinations and
Yeah.
see which one is the shortest.
the problem is, no, you can't brute force it because it doesn't take much for something to combinatorially explode when you talk about vehicle routing, right? Because if you have 10 cars and there's 10 pickups and drop-offs, think about how many combinations there are. There's almost no way you could brute force that. So you need to have
Maybe 3 to 4 limited, then it is fine.
it's dependent, but no, if you only have 3 pickups, then why are you using operations research to solve it? Like if you can just hand do it, why are you gonna implement something for it? But yeah, so it's very dependent, but they grow really fast. So it doesn't take many vehicles, it doesn't take many ride requests before it gets really out of control. So you have to fall back on operations research, like optimization techniques that are well known. There's no brute forcing it.
Also, let's say you have to solve this overnight, like everything is scheduled. Then do
Okay.
you also take into account the cost of computation, like cost of solving this?
We didn't do that because the amount of money you would spend on gas, like the amount of money you're saving on gas and time and having people driving cars is gonna outweigh the cost of the compute power.
Okay, you already
Like,
know that. Okay.
yeah, that's usually the case.
The input data, then how do you, so is that data something that's the company's been collecting for a really, really long time, or is it
Yeah,
something that's like an ongoing process where like continually collecting data and improving offline?
Yeah, so this is one of the interesting things about optimization problems is they're not data driven like traditional data science. So traditionally data science, you have data that you collect and then you get insight from the data, right? But with a lot of these operations research and optimization problems, you're really not using data to find insights. You're coming up with what is your objective that you're trying to solve for, and then you have different constraints. So let's walk through an easy example. So my objective is save time, right? Like I want the fastest way to travel around the city doing pickups and drop-offs. So I have an objective, and then I have different constraints. So constraints would be things like I have to pick up person A's stuff before I pick up this other guy's. Like maybe there's some sequence, or maybe there's a time window. So like person A is only available from 10 to 12. This other person's only available from 11 to 1, and there's like different constraints, right? And then drivers have constraints too. So like a driver, like especially when you do truck driving, there's laws that say they can't drive for so many hours straight. They have to take breaks. So you have constraints, you have an objective, and then you use some mathematical techniques to solve the optimal solution. So what comes out of these optimization problems is actually a decision of what sequence or how you should schedule the planning. So that's the main difference between like data science and operations research.
So just
basically
something
you're
in the
not-
mathematical. Oh, sorry. Go ahead.
So
Ashit.
well, the data. So like the only data that really changes. So in that case, like you know your objective, you know the constraints. Those don't change. Like there's no data that would make them change besides the constraints themselves. But the data that does change is the actual like how long it takes to get from a point to a point, right? Because that determines how you should do your sequencing. So for that, usually what you do is you have some mapping provider. Like you could use Google Maps to get that information, or you could use Here Maps. There's a lot of mapping vendors that you can use. So if you wanted to add data science on top of the optimization model, like one in vehicle routing, one good example of that would be how accurate is your time estimation to go from point to point, because that affects your overall solution.
Yeah.
Ashit, you had a
Also,
question?
if there's any other road that has been created newly, right? That changes the time for every point basically. And also this is more of algorithm based and
Yeah.
not exactly data based, right?
Yes, exactly. It's all algorithm based. It's not data driven.
So we
Yeah,
also
for
use
sure.
live traffic as an like data point here, like because I was also working with one of the retail company, which is like quick commerce company. So what they generally do, like whenever a partner is assigned to some task, they also take the live locations of the point and also the traffic situations of that point. How is the traffic at that point of time? So do you guys also use something like that, or
Uh, for the problem we're working on, it doesn't make sense to use that, because just inherently that wasn't an issue. A lot of what we were doing was ride hail applications, and they were really short term. They weren't like cross country driving, so that didn't really come into play. And I think that when you look at live traffic, really the main difference when you use live traffic is how that individual car is going to now operate. It's not really how the fleet is going to rearrange itself. Usually if one car is stuck in traffic, maybe they will take a different path to get where they're going, but the original schedule probably wouldn't change much. But again, this is dependent on the business problem as well.
yeah?
So let's go on the business side a little bit, right? So we talked a lot about technical side. Now on the business side, right? So how how is all of this problems that you've been working on, or the team's been working on, how is this beneficial to business, and also how do you convince, right, to the stakeholders in terms of using any of this optimization problems, algorithms that you've been using, and also how do you convince them in terms of resources, right? Like you mentioned, right, some optimization algorithms require high computing, and we often see in companies that they are not resources are not available at times, and that's also one of the reasons why like stakeholders, it's hard to convince them, right, to give you the resources that's needed in order to solve particular problems. But sometimes people have to find a way around it. So in your scenario, was it the case? And how do you convert this into an actual business problem where the company knows the company can make some money out of it?
Yeah. So yeah, I mean, the first thing with any problem, you have to understand what's the business objective. Really understanding why is that their objective too. So sometimes a business, they might tell you something, but they mean something different, right? So like really understanding and working with them is the first thing you need to do before you even start the project. Secondly, there should be some metrics that you're trying to hit. So when you want to know if something is acceptable or not, there's usually some guidelines that you have. In the vehicle routing case, a lot of the problems that we were working on had service level. Basically we were an API that companies could call to get schedules, and we had service level agreements based on the type of company. So some companies that were doing real time, of course, you need to have something quick because we'd have like a 1.5 second service level agreement. So in those cases, it's obvious which type of optimization technique you would use because there's only a few of them that can run that fast. When you get to if you were to put a slack on those service level agreements, maybe it's not as obvious, and you might wonder, well, why do you want to have something run for a long time or high compute? Like, is it worth it? So that all comes down to the business as well. So if you can have a program run for an extra 5 hours and it only gets you 1% better, maybe in a vehicle routing problem where you're doing like a ride hail situation, that doesn't really matter, right? Like, what's 1% going to save you? But if you're talking about manufacturing and 1% of every box that gets sent out, maybe that starts to add up, right? So 1%, depending on the application, makes a huge difference. So I think, again, you have to really understand the business context in order to make that decision.
Yeah, I completely agree on that. And there's a friend of mine so works at a startup, and so one of the business guy, so he was in charge of Kubernetes, right? He was paying for Kubernetes services and so on, right? Now they've been losing, I think, $10,000 worth of dollars every single month on running Kubernetes, but no one was using it. So it was a waste of money, but they didn't realize it. I think for almost a year, they've been wasting all that money, right? And no one in the team is actually been using it, right? But the technical guys knows, if they were given a charge of, where to spend the money on what resources and so on, now they could have saved that money, right? But because this business guy, he was in charge of it and he wasn't sure about all the technical stuff that the team's been doing and what is needed, what's not needed, and how much money to spend and so on and so forth. Right? The team's been the company as a whole, went into a huge loss for a year, right? And obviously at the end of the day, they found out and he got fired. But so it's something to think about, right? And always start with the, like Adam said, always start with the business problem. Think about business problem, and also the second thing is, knowing whether you really need machine learning, right? If we can get away without applying machine learning, it's good. It's good for you. It's good for your company, and you don't have to go, apply complicated machine learning algorithms or make it sound fancy. That this is a machine learning product just because it sounds fancy, and people will buy it and so on and so forth. But at the end of the day, you're making a huge loss for the company if it's not really needed. Right?
So I
and
think
you bring up an
so whatever Adam just covered till now, I don't think anything has had anything to do with machine learning at all till now, right?
Yeah.
Am I right?
No,
Yeah.
not really. No.
Yeah.
Yeah.
So
Yeah,
but you bring up another point too when you talk about Kubernetes, right? Like, one thing that I think is very important for data scientists, which is often overlooked, is you have to have this holistic view of the whole product, including how is it going to scale and how are you going to engineer it. So I think if you can learn some software principles, software design, software engineering, it'll take you a long way. So more for people that are starting out, learning when you need to use certain things, when you don't, and then also the business trade-off, right? Because if you start going to big, deep learning problems, it costs a lot of money to train, costs a lot of money like in time because you have to spend time training it. You have to review it. You have to update them frequently, right? The model can get stale quickly. So that's all things that you have to consider.
Yeah. So it's a point for for people who are out there and who are thinking about machine learning, data science. They're thinking about applying complex algorithms and trying to learn complex algorithms and so on and so forth. So just so you know, right? How you should always start whatever project you're doing, right? So how you should always start in terms of whether you need machine learning or not. Always start from the business problem, right? And once you start from the business problem, you'll see the direction in which direction you have to move and so on and so forth, right? So coming back to your point about software
I
engineering
have
principles,
one
how
question.
valuable? Yeah, go ahead.
So I'm curious to know whether did you have a product manager in this product that you were developing for maybe the vehicle routing problem?
Yeah, so in all the projects that I've worked in, we've worked in a agile, like a Scrum. We use Scrum. We were in these agile product teams. So usually it was a mix of so you'd have your data scientists, you'd have your or operations research scientists, and then you'd have your software engineers, your dev, which also doubled as your DevOps team. And then you'd have your project manager and your project owner as well. So I was fortunate that a lot of the teams I worked on were self-sustaining product teams.
So does the involvement of a product manager make it easier for you to just stay within data science and not deal much with the business, or is it the same?
I think they help to, so really they help to set what you should be doing. So they kind of give guidance on what's the product vision, right? Like what is the vision of the product from a business perspective? And you need to help them fulfill that. So I look at the role as almost like it's almost like you're doing consulting work for the business at the same time. So you can't just blindly do what they ask, because sometimes they don't know the consequences of what they ask for. So you need to tell them, okay, we can do this, and we can go in this direction and do it as you want, but there's a trade-off. Like maybe it's going to take 3 months longer. It's going to be harder to maintain, and try to quantify what that means, right? Like we'd have to train it every month or whatever it might be. It's very specific to the problem. So kind of your role is giving them different trade-offs. What are the consequences? And then helping them make informed decisions. So that's your number one job. And then after that, you can start working on implementation. And it's more important as you grow in your career to be able to talk with the business and help make those informed decisions. I think when you start out, you kind of heads down working on tasks, following what the seniors do, but you should still try to get involved. That's probably the advice there.
So I was talking to one of the product managers at our company, and something funny he said, right? He was like, yeah, we make informed decisions based on the things that you guys provide as the data teams, but when things don't turn out well, when you launch the products and when things don't turn out, we are the person who get blamed. Basically, the product team is the one who gets blamed when things don't turn out well, right? It was funny, right? When things go well, everyone gets the credit. Oh, there's a data team who was involved, there's a product team who was involved, and so on and so forth. But yeah, when things they go down, because we are the ones who made decisions based on the things that you provided, we are the person who the company will blame on. So it was kind of funny.
Yeah, you don't. I mean, that's dependent on your company too. But like
it's just
some
a funny
product
kind of joke. Okay.
Yeah, that I've seen things like that happen. But I mean, part of it is that's how you really need to explain the risk of what you're doing as well, and you want to do that so that it covers you as well. So yeah, we can do that approach, but it might take this much longer. Like telling them the quality versus time trade-off is important, but you have to actually you have to know how much time it's going to take too. So like that's part of the software side, right? You have to have a good understanding and a good intuition of how different algorithms and different approaches that you take are going to affect the overall product.
Mhm. Yeah, that's a valid point, and that takes me to another question, right? So knowing the boundary and knowing the capacity of how much a data science can or their data team can provide value, right? So I see a lot of organizations where uh, sort of the managers, right, if they are business oriented uh, candidates or um, and they don't have a boundary as to how much is possible and how much is not possible by the data team, right? Sometimes they want things which is sort of impossible to provide because it's beyond the capacity of what the data science team can do, either because they don't have the data that's needed in order to solve the problem, or they don't have the resources that's needed. So, how do you separate, and how do you show that boundary basically to stakeholders? And, you tell them no, like, hey, this is not possible because
Yeah,
of this, or this is
that's a good,
possible, we can do this.
yeah, that's a good
Yeah.
question. So first, I think I always tell them almost anything is, we can do anything you want. The question is, what are you willing to sacrifice for it, right? So we can do what you're asking, but it might take, like, that's a 2-year project. And you don't want to get into the habit of saying yes to everything that the business asks, because then you're going to put a lot of pressure on yourself. And if you're a lead, your team's going to take that pressure, right? So you don't want to say yes to everything, but you don't want to say no to everything at the same time. But one good piece of advice is, don't try to argue points. So, they want something, you want something. You're not arguing for this or for that. Try to come up with different alternatives that satisfy both parties, right? So maybe we can do the product owner's vision in the long term, but temporary, I can come up with some solution that satisfies most of the needs, and I can get that done quickly. And then we can always iterate back on it, and we can learn more as we go. So trying to come up with an alternative that kind of meets, in the middle, if you will. Instead of it being a yes or no, it's, what about something else? So proposing alternatives is a key thing. And then, yeah, trying, I mean, that's kind of the key. Propose an alternative, and then explain the trade-offs, and then iterate on it too. So tell them that just because we're doing this, just because we're meeting in the middle now doesn't mean we can't do it later. And maybe once we implement something, like, something is better than nothing most of the cases. And that's kind of the whole agile mindset, right? Getting something out that's usable, and then getting feedback from customers. The quicker you can get feedback from customers, the better. So you don't want to spend a lot of time before the customer sees it. You want to get it in front of the customer as quick as possible, even if it's not, complete as defined by the business. Sometimes it's better to get that feedback, because you might be going in the wrong direction anyway. So I think trying to succinctly and, trying to explain that to the business is a skill that we should work on.
So has there ever been a time when you had to say a hard no to a requirement?
Yeah, I mean, it happens all the time. So a lot of it has to do with tech debt too. So sometimes they want to make a change, but you just can't do it. So you just got to tell them. Like, this just happened to me recently. I'm working on a parts recommendation engine it's a recommendation engine for how do you recommend different accessories that go on vehicles when vehicles get ordered and shipped to dealers. Well, they want to change a part of the way that this gets recommended based on some business insight that they discovered. But this is kind of an older recommendation engine, and being able to just throw that business insight on top of it isn't really possible. I mean, sometimes you just have to tell them, no, we can't do it. This is the reason why. But I did give them an alternative. So, like I was talking about, so I can't do that. It would take me, probably 6 months to put that change in. We don't know if it's really worth it. right? Like there's some business insight that's telling you it might be valuable to go that route, but we really don't know. Well, what if I just did this little heuristic on top of what we have? It kind of gets you to what you want, but then we can actually get feedback from the customers. And once we get that feedback, we can determine, should we spend 6 months doing it, or should we just drop it or leave it as it is? So getting customer feedback is probably one of the most important things.
So for people who don't know, right, this is something called MVP. So you must have heard about MVP products. It's something called minimal viable products. So build something quick, roll it out, see what customers like, get their feedback, and then iterate over it, try and improve it, right? Rather than spending months and months and months on building the whole thing and then rolling it out, right? And the other thing is again, people who haven't worked in industry, this is a valuable point. Don't try and keep on improving. So to set back, right? So I was working in academia, right? And academia, this is the mindset that people have, right? Improving the results as much as possible, right? Without ruling it out, right? And this is the same thing that I see a lot of people doing in industry as well. People stick with if they're building a machine learning algorithm or something, they won't roll it out until it hits the results that they want, right? If it's 98%, they want to make it 99% accurate. Until then, they're not going to release it. And this is bad, right? You should be releasing the product, and if the 98% product is doing well enough to customers, and if they're happy with it, why not release it, right? Why wait until you want to take it to 99%, and which is again gonna take you a couple of months. So instead of that, give something to the business, so at least the business can take advantage of it, and also in the process you're learning by your customers, and what is it that your customers like and dislike, and so on and so forth. And if it's not worth it to improving it further, then you can spend your valuable time on something else, which is important, right? So always think of any project that you do, think of it in terms of MVP products, right?
Yeah, and if you go one level higher than that, right? Like what you're saying, maybe 98% you roll it out. Sometimes getting that extra 1% is just not even worth it. So you might be able to do it, but there might be a different business problem that has a quick win. So you got to keep that in mind, just like you said.
And companies don't really care about your algorithms, how good they are. They don't care about that. All they care about is how much value are you bringing in. That's all they care about. So just keep that in mind when you go out in industry, and also when you're working on your personal projects. Keep that in mind, and spend more time on converting it into business problem, right? How businesses can take advantage of the ML use cases and so on and so forth. Any questions from anyone? I'll pause here for a few minutes to see if people have any questions. Again, it can be anything. It doesn't have to be about data science and supply chain and automotive industry. No questions? Okay, so I guess I'll go ahead with the question that I have. So yeah, something you touched on earlier, software engineering principles, right? Go ahead.
I don't have any question, but I'm just asking if anyone is trying on building LLM from scratch.
Not me. Anyone else?
Not LLM, maybe SLM, small language model, because we cannot build LLMs from scratch with the budget. Any small data set, did anyone tried with transformers architecture to build right from scratch?
So why do you need it from scratch? Is there a reason why?
So you'll understand better, and you can tweak the accuracy and performance given to your context.
Yeah, no, I don't think I haven't tried. I don't know, but Ashit, Adam, you guys?
No,
No.
I don't have a need
Mm.
for it, so it's kind of outside of my domain there.
Yeah, same here.
Could be
Yeah,
a
so the
learning
answer
experience.
is no. Mhm. Yeah, so unfortunately, no one's tried it. So yeah. Okay, so moving on to software principles, software engineering principles that you mentioned earlier, right? So a lot of beginners, right, come from data science. They usually come through your self-learning or taking boot camps, uh, and so on and so forth, or virtual classes and so on. I think the most important chunk that they miss out is learning the software engineering principles and how that can be applied in data science, right? And they don't see the value of it until they get, even if they start working in organizations, because organizations are not up to date in terms of having good
Right.
standards, having software engineering principles within their team, and also depending on if it's a technical guy versus a business guy leading the team, how knowledgeable that person is. They still don't learn those principles, and they're even not aware about it, even with 4, 5, 6 years of experience, right? So how valuable you think these principles are, and in terms of long-term goals that the company has or the team has?
Yeah, so I have had, I think they're one of the most valuable skills that you can get, and part of that is because of the teams that I've been on, and I've seen how if you get data scientists that understand software, I've seen how much better the product can be. So a lot of data science projects fail, right? And that's partially because they don't get deployed. They never make it to production. They never get used. Um, I'd imagine a lot of that has to do with the fact that a data scientist, like you said, in academia, you're just learning the modeling and maybe use some Jupyter notebook. And it's really not that accessible to software engineers, and it doesn't integrate well into an enterprise technology stack. So how do you need to be able to create your model with with this understanding of how it's going to be used and how it fits into the software side so that it can be released, right? Like you can have the fanciest model, if nobody uses it, what good is it, right? So having that software understanding is very important. Then it also, like, from a career perspective, so that's from a business perspective really, like, but from a career perspective it's also very valuable because now you can work on some of the more interesting projects as well. So a lot of data scientists kind of work more like data analysts. There's a large overlap with data analysis, and maybe they're building like simple predictive models possibly, but it's kind of can be run isolated. But if you want to get into like real time applications, you have to understand the software. So you need to understand like architecture design if you want to do things that happen in real time. So you can't have a slow model. Like if you want to compete with a technology company or join a technology company, you need to understand what sets them apart. And even from business perspectives, like like we were talking about with routing, or if you put a ride request into Uber, you don't want to wait 20 minutes to get a response, right? So you have to understand how that all plays together. It also helps you get it launched into production because now you know what software engineers are looking for. You know how to make it more maintainable. You know how to write good code that's somebody else can come in and read it and actually understand what's going on. So I think it's one of
Yeah.
the most important things that you can learn.
Yeah. Yeah, I spoke to, so a lot of people reach out to me, right? And they're like, I'm applying for jobs and, haven't had any response and so on and so forth. And, if there's anything you can help with and so on. And the first thing I do is when I ask them to code, I'd be like, okay, show me how you code, right? And I see their code and I'm like, I can tell why you're not getting jobs, right? You've been a data scientist for these many years, X many years, but what's the most valuable skill that you were supposed to learn? You haven't learned it in these many years, right? So the one advice that I was given by at Decathlon by my ex-boss was basically, acquire skills and skills which are in demand, right? But at the same time, acquire skills which are, data scientists are still trying to adapt their software engineering skill sets needed. And if you're lucky enough to be in, one of the good organizations where you have a team who's been, adapting those skills and are already in place, and you come along and you learn those skills, right? It's good for you. But if it's not, then you should really learn those skills, and get to the point where any company should come to you, right? You should be valuable to any organization. It shouldn't be the other way around, right? So make companies come to you with the skill sets and with the things that you're in, rather than you going after companies and comes one after another and getting rejected. And this also helps you with with the salaries, right? You can demand more money as compared to someone else, right? Now, if my skills is this much and Adam's skills is here, right, in terms of everything, right, in terms of coding, following software engineering principles, so on and so forth, right? And Adam can demand more money, right? Because he's got the skill sets and he's got things that is good enough to help with the organization in setting up their long-term goals. So that's one advice I was given, right? So, and in a year, right, it's been a year since I've been at Decathlon, and the way I was a year ago, Jupyter notebooks. That's all I used to do. no software engineering principle, nothing, right? I was a really bad coder.
Even so, these real-time applications that I'm talking about, you can't use Python to write these because Python would be too slow. So the first 3 years I was mainly writing everything in Java. So, and how many data scientists know Java or C++? Not that many.
Yeah.
So that helps you get on, that helps you get more money, helps you in your career, but it also helps you work on cooler projects. So
yeah,
learning that
I agree.
is important.
Mm-hmm. So one last thing I want to mention before we wrap up is, because I think it's been an hour. So any advice for beginners or mid-level data scientists that you'd like to give them in terms of career, in terms of how they can go level up in your company, in their companies? Yeah.
I think some of the, contrary to what people think, I think some of the best ways to advance in a data science career is more on the soft skills. So being able to talk to the business team and being able to expand your network is invaluable, right? Like a lot of jobs that people get are not from blind applying. It's from they know somebody who gave them references, and that goes a long way. Also, learning how to communicate based on who you're talking to is a big differentiator. So as you start to, you would think that going from junior to mid-level to senior, you're getting more technical, and you are getting more technical, but you're also learning to not be more technical at the same time. So really understanding that is probably the most important thing. You have to understand the theory and know when to ignore it. That's kind of that was what one of my advisors once told me. So
Also,
I think
how about showcasing your work publicly? Any
yeah,
thoughts about that?
Yeah, self-advocacy. Like you need to. I mean, everybody's gonna boast about themselves, right? So you need to do it too. So don't be shy about selling yourself. Having public work. Even using LinkedIn, just going on there, writing your thoughts, talking with other people, that'll help you out as well.
Yep. Just remember, the world's getting complicated, right? And the demand in data science, it's very competitive, right? There are more people now than there used to be maybe 5 years ago. So now, any role that you want to get, you have to, compete with so many people, right? So always, remember the things that can help you make it easy for you to land it out, right? And get past that competition, right? How can you, get past the competition. So there are so many things that Adam has mentioned, and you can take advantage of that to get past it.
A lot of
and,
it's
that's Mhm.
a lot of it's perception too, right? So even if you have let's say that, two people that worked on the same type of project, like in their spare time to do as a portfolio project, and one of them is better than the other from a technical perspective, but one's looks a lot better, it has a website, like you can view it, that actually goes a long way as well. So how you
Yeah.
market is it is more important actually. Now, should it be that way or not is a different story, but that's the game, and you need to play the game, right? So
Yeah.
like whatever you need to try to market yourself. So if you can make it look good, that also goes a long way.
Yeah, that's good. Okay, well, thank you so much, Adam, for joining us today and sharing all your experience. I think people have learned quite a lot of things. I personally have learned a lot, so I didn't know anything about this industry before, but in an hour, I think it's good enough knowledge that I've gained, and hopefully people have enjoyed it as well. So before we wrap up, I just want to mention one last thing that me and Ashit, we are offering, and includes basically everything that we've talked about today, right? And we started offering this because, again, like I mentioned, right, we see a huge gap between boot camps and what the industry requires of data scientists, right? And to fill in this gap, me and Ashit, we started sort of offering this mentoring program, the data science mentoring program, where it's not only data science, but we're also teaching sort of bits and pieces of data engineering as well as DevOps or MLOps side. Because I feel like, as a data scientist, depending on, what kind of organizations you go to, it's good to be aware of these different branches of data and, how one falls into another, right? They all overlap with each other, right? And knowing, how they all overlap, and is there anything that you can do to, help speed up the process? Some organizations, you might even end up doing multiple things. That's the reason why we put this together, the mentoring program. So the whole idea of the mentorship program is basically, you would come along, you would work with me and Ashit for a period of 2 months, and we would design an end-to-end data science project. So starting from data collection all the way to deployment. And the other reason why we started this was because of, the money that the boot camps charge people. It's crazy. And the amount of things that people learn from those boot camps, it's, that can be learned from Udemy, from Coursera for minimal cost, right? So you don't have to go and pay thousands and thousands of dollars to learn all those basic stuff that the boot camps will teach you. And there are so many boot camps out there, right? There's one after the another, and it's just crazy how much they're charging. That's the reason why we started this whole thing, right? So single project where you'd build an entire pipeline, just like you would in an organization, right? And in the process, you would learn all of these skills, right? So you would learn how to use Python. If you're interested in R, you can learn R. The cloud services, we use both in this mentorship program, AWS and Google GCP. There's SQL. You depending on whatever flavor of SQL you would like, Postgres or MySQL. Then there's GitHub. Again, a lot of organizations don't use GitHub, and people are still, people been working as a data scientist for many years. They don't even know GitHub. So how do you use GitHub in collaborative mode, right? So that's one thing. Then CI/CD. This is something that's becoming valuable when it comes to deployments, right? So we're teaching people how to do CI/CD. And the thing that Adam mentioned today, right? The important skill to have, software engineering principles. So we're teaching how you would follow the cycle of software development, right? When it comes to working on projects and so on. So we have a question. Yeah, go ahead.
Not question. Actually, I work on Azure platform. I am disappointed why I have not introduced.
The reason why I haven't included, again, this one, I mean, we just started this, I think, a month or two ago, and so design this entire pipeline. Because I don't know Azure myself, I haven't used Azure. Anyone in my organization uses AWS and GCP, and also I don't know the amount of money that I have to spend on Azure, if it's free or how much money I have to spend. So this is something like you said about minimal viable product, right? So this is something that I built the entire pipeline with the
I
tools that
thought
I
you have
already know.
partiality towards Azure.
Right? Yeah, I mean, knowing one cloud platform, it's easy to jump on another, right?
Yeah,
Same thing with
same.
programming, right? If you know one, you can jump on the other. I started out with R, and I now use Python a lot. I use R as well, but still, right? So Azure will be something that we'll keep in mind, and we'll bring it along going forward, figuring out the cost and so on and so forth. But yeah, for now we have this.
Now, can you include mathematical concepts, something that also will be helpful, right? For the people?
So we are okay. So the goal is basically to show people, how they can go from A to B, right? And how they can, in the process, how they can build this and design this entire pipeline, right? Now there is a modeling part in this. So I mentioned that here in the project details. So there is a modeling part in it. But we're not spending months and months teaching all the different algorithms that exist out there, but rather, let's go pick up a couple of algorithms. Let's apply it. And whatever those couple of algorithms that you would pick, on that we would do a detailed learning about it, right? Because one thing I've learned is, no matter, even if you know all the different algorithms, there is a high chance that you're not going to apply every single one of them at work, and you will forget these algorithms, right? I've learned like everything when I was trying to get into data science, but now I don't apply everything. I don't even remember. If someone asks me what is random, explain me in detail what is random forest, what are the, I don't know, metric and so on and so forth, I'm like, I don't know, because I haven't applied in past 6-7 months. So so knowing, but I've learned it before, so it's easy to go and quickly read up and bring back my memories of decision tree, right? So that's the reason why we haven't included that, right? And it's also a 2 months project, right? So it's really difficult to teach everything in 2 months, but we'll put together valuable things that you would have to know, and it's something that boot camps don't teach. So yeah, so this is a project detail, right? You'll be learning about data engineering, there's data science, deployment side as well, and all the tools that one needs to know. So there is that, and also agile approach, right? So it's always that's another thing that we're focusing on. We're focusing on, how do you start with a business problem, keep that in mind while building the entire project, and also the agile approach, right? So build something quick, come back to it, take a feedback, and again repeat, right? Now, where do you get the feedback? Well, once you build the entire project, so we have Ashit, me, Sushant, we basically make our students present to us. So we are the clients. So you'll be presenting to us the entire project, and then we'll be giving feedback and so on, and you would go out and iterate. So what do you get out of this? Well, you get to work in collaboration with me and Ashit. And like I said, the project can last for 2 months. It took me about a month and a half to build this entire pipeline myself. So it's doable. And we have 3 to 4 students right now. One of them already completed the entire project. The other 3 are in the process of finishing up in a couple of weeks. So yeah, it's doable. And the basic thing that we ask people to know is Python. Because we know when I teach Python, if you want to learn Python, then there'll be additional month to teach you the entire Python and get up to speed. But knowing just the basics in Python, how to define functions, how to define variables, list, dictionaries, that's good enough. We don't expect you to know everything else. And the other thing is it's one-on-one mentoring. So we are investing our time in you, basically. I invest at least 10 hours a week into students. That's the amount of time that I'm investing. For me, is it worth it? Well, for me, I'm not making like enough money at all. I make more money at my work if I were to invest 10 hours more. But it's a way to help the community and to help others to get to to speed and to basically upskill them, right? That's why I'm investing my time. So you can reach out to us on this email. We have a form link. Ashit can put it in the chat. And yeah, you guys can reach out to us or reach out to us on LinkedIn, and we'll, we can talk about it more in detail. And that's about it, I think. Any questions people have about anything? I'll spend a couple of minutes. We'll stick around a couple of minutes. If you don't have any questions, we'll call it today. But
No questions, but it sounds good. I think you're filling the gap, right? That's the major gap that you get with like taking a Udemy course or especially being in a university. Like I see a lot of people come in and yeah, they're missing the software side and they're missing that business side. Like how do you develop things in an agile fashion? So
exactly, right. And like me, just like every other people. I've taken so many boot camps. When I was trying to get into data science, and all that the boot camps will teach you is the basics, right? Even like industry job, even getting a job at Decathlon, right? I was lucky enough actually at Decathlon. Like my boss was pretty open-minded in terms of you don't need to have everything. And some organizations, they be like, okay, you cannot Google anything. You just have to know everything, right? And I'm like, well, you yourself would be Googling if you don't know everything. You're just spending time on Stack Overflow. So yeah, like it's something that I felt like, okay, you know what? Company boot camps should really start offering these things for the amount of money that people are paying. If they're not doing it, then me and Ashay were like, well, let's do it. And the amount of money they charge, like we don't even charge 10% of what they charge. We probably barely charge 5% of what they charge. And that's the other factor. Like people cannot pay that much. It's huge cost. So yeah. Okay, no questions from anyone. Let's wrap up. Thank you very much, Adam, for joining, and thanks everyone for joining today and for all your beautiful questions. Have a good day and have a good night.
Thanks, Adam.
you.
Good day for me and Adam. Everyone else, good night.